Hey guys, let's discuss new topic from system design, which is called load balancing. Okay, so okay, let's say you have a user, and then you have some your microservices, okay, microservice architecture, and then user is sending request to these servers. Now let's assume that you have millions of users in your website, and then they are sending the request. So how you will handle these millions of requests? Okay, so using load balancer we can do that. So load balancer will stay here between your client and your server, okay, and then it will distribute request evenly, okay, or will use some strategies or some algorithm to distribute the request. So have you ever thought that how this WhatsApp, Netflix and YouTube, these systems are handling these millions of requests? Okay, so using load balancer we do that, we achieve that. So load balancer, what it does, it distribute incoming request, okay, incoming request across multiple servers, so which will avoid overloading. Okay, so one server will not get much request, so overload, it will avoid the overload. Second is it will improve performance, okay, and then third one is it will ensure high availability, all servers are available. Now let's discuss about type of load balancer. Okay, so the type of load balancer is layer 4 and layer 7. Okay, now what is layer 4, layer 7? Do you remember OSI model layers? Okay, so let me tell you, there are 7 layers in the OSI model. The first one is physical layer, okay, second one is data link layer, third one is network layer, fourth one is transport layer, then session, then presentation, and after that application. Okay, so this is first, this is second, this is third, fourth, fifth, sixth, seventh. Okay, so we have remembered it like please do not throw sabzi paratha away. Okay, so here you can see layer 4 is your transport layer and layer 7 is your application layer. Okay, so this is your OSI model, and when you just take only these 4 layers, it will be your TCP/IP model. Okay, these 4 layers will come into TCP/IP model. So here the 4th layer and the 7th layer means transport layer and application layer. Okay, these 2 layers. So this one is layer 4 and this one is layer 7. Now in layer 4, now what is the difference between both type of load balancer? Okay, these are the types of load balancers. So in layer 4, layer 4 works on IP address and port number. Okay, so means so to this load balancer, okay, user will tell this is the IP address and this is the port number, so just go to that server and on that port, okay, and just send the request. So this is kind of a dump. Okay, he doesn't know that what this request will do, what is the purpose of this request. Okay, he's just going to that location and then he's just sending the request on that particular port number. So this one is fast also. Okay, now the second one is layer 7. So in layer 7, this one will work on HTTP, okay, and HTTPS, okay, or you can say URL is something like this, slash images, okay, or slash API, something like this. If it is slash API, then go to this server. If it is slash images, go to that server. Okay, and then it will work on headers also. You can send header, okay, and then cookies as well. So these are the now this one is definitely slower than layer 4, okay, but this is the smart and very efficient. Okay, so now let's discuss the algorithm of the load balancing algorithms. Okay, means in how many ways you can balance the load in load balancer. So the first one is round robin. Okay, the first one is round robin. So what round robin does, see, let's say you have a server 1, server 2 and server 3, okay, and you are getting request 1, request 2, request 3, okay, and request 4. So what it will do, one by one, turn by turn, it will send request. So for example, R1 will go to S1, R2 will go to S2, R3 will go to S3, okay, and then R4 again will go to S1, then you will get R5, so that will go to S2, then R6 will go to S3, okay, and then again R7 to S1. So turn by turn it will send the request. So this is very simple, but the problem is, let's say each server has different capacity, okay, so according to their capacity it should distribute the request, right? But here it is, he is just sending the same number of requests to each server. So that is the problem. Now the second one is weighted round robin, okay. So in weighted round robin, what you will do, you will assign some weight to the servers. So for example, I've assigned 100 here, 200 here, and 300 here. So it means that this server's weight is more, okay, so load balancer will send more requests to this server, okay. Now this, so that one was the weighted, okay, weighted round robin. Now the third one is least connection. So what is least connection? So as name is saying, okay, the server which has the least connections, least number of requests, so it will send request to that server, okay. Now or you can say least active connections, okay. The fourth one is IP hash. So IP hash is something like you have a one user, okay, this request is coming from one user, let's say user 1, okay, and I want this sticky session. What is the sticky session? So first time this request goes to this server 1, okay, so second time again if the user will send the request, it should go to session server 1 only, okay. So I have that session is sticky with me, okay. Now what is the problem with this sticky session? So the problem is that every time the request will go to this server 1, even if I add more server into the into my architecture, or I reduce the server, this user 1 will be unaffected with this scalability, okay. And then if this server get crashed, so the data will get lost, okay. So that is the problem with IP hash session, sticky session, you can say. And then the fifth one is consistent hashing. So consistent hashing, I have created one video lecture, okay, very good video lecture. So I have explained everything about consistent hashing there. So in consistent hashing, let's say you have a server 1, 2, and 3, okay. Today if I change, and these requests are mapping to this server using some formula, let's say. So that is your hash key mod n, where n is the number of server, okay. Right now I have 3 servers, so I will I'll do hash key, okay, find the value of hash key, where key will be the associated value for each request. I'll get some value, and then we'll find a mod of n of that. So today if I change the value of n, today it is 3, if I make it to 2, means I remove one server, or if I make it to 4, if I add some server, so my value of this expression will get changed, okay. So it means that the request 1 was pointing to S1, okay, was going to S1, now we'll go to somewhere else. So it means that I have to reshuffle all the requests, okay. So the solution for that was, I will place these servers into the hash ring, okay, and will now let's say if the key request fall here, okay, so who will cater it? The next available server in a clockwise direction. Similarly, if request fall here, so who will cater it? This one, okay. So this is called consistent hashing, and I have explained it very deeply in my video lecture. So these 5 algorithms are there in load balancing, okay. And the type of load balancer we have checked, layer 4, layer 7, okay. Now let's discuss some few more topics on load balancing, okay. So let me remove this. So now there is one question, that how load balancer handle the failure, okay. So how he handle the failure, let's say you have a, so this is your load balancer, okay, and you have some server 1, server 2, okay, server 3 in the network, and let's say this server 2 gets failed, okay. So how he will know that this server 2 gets failed? So he don't need to send request to this server 2, Okay, so he will continuously ping, okay, to these servers, HTTP pings, and once he will not get the response from S2, he will know that okay, some problem with S2, so he will stop sending requests to S2, okay, till further notice. So that is how load balancer handle failure, okay, in a network. Now there is one more load balancer you can call DNS based load balancer, okay, DNS based LB. So DNS is your domain name server. You know that when you type google.com in the URL, okay, it will go to DNS server, it will give its equivalent IP address, and then it will redirect you to that you will get redirected to that IP address, okay. So DNS based load balancer is the same, okay. User will send request to DNS, okay. User will send request to DNS, and then DNS will have a load balancer, okay. Let's say three for that particular website, he has a 3 load balancer, okay, 3 servers. So he will give IP address for all 3 IP address to user, and user will choose one of them, okay. So that is how you use load balancing in DNS. But the problem here is user can cache that session ID, that IP address, okay, and then every time going forward he will make a request to that server only, okay. So that is the problem. It is not a real load balancing thing is happening here, correct? So for that, to overcome that, okay, there is a concept called anycast routing, okay. So in anycast routing, what will happen in a network, you will have a multiple server, but each server will associate with the same IP, okay, same IP address. So in that case, even if user cache that IP address, okay, and he will make a request to that IP address, it will go to different servers every time. So that is how we overcome this problem, sticky session problem, okay. Now what is the issue with the sticky session if we talk in detail, okay. So the issue is uneven load, okay. Uneven load means only request will go to this server only every time, okay. So that is the issue, uneven load. Then second is poor scalability. If today I will add one more server in a few more server in a network, so it doesn't matter for this user and this server, right, because user is associated with that one server itself. So scalability not much affect user, okay. User cannot take the advantage of scalability, you can say. And then third thing is failure issue. So if this server will get failed, okay, then the user data will go, right. So that is the problem, and the solution for that is use distributed cache, okay. Use distributed cache like Redis or Memcache, okay, and you store the session information there. So this architecture is called sessionless architecture, where you are storing that session information in a distributed cache. So it is not associated to particular server. In a distributed cache, everybody can access it, okay. Now what will happen if you use caching with the load balancing, okay. So let's see. So caching with load balancing, okay. So what load balancing does, load balancing will distribute your request, okay, evenly. So you can say that it will reduce traffic from server, correct. So this is what LB does. And then what cache will do, so cache will reduce repeated computation, okay. So it will reduce repeated computation, which is happening on the server side, right. It is not now your application before hitting DB, it will check in cache, and if it is there, then it will just get data from there itself, okay. So here you are reducing the computation, and load balancing is reducing traffic. So both will combinedly will make your system very efficient and scalable, okay. So that is the good thing. Now just 2 minutes. Okay, now what happens if load balance, what is the bottleneck here, okay. Load balancer itself is a bottleneck. Why? Because you have only one load balancer. If it will get crash, okay, this is the single point of failure, you can say single point of failure, okay, is POF. So single point of failure, if this one will go down, okay, see, user doesn't know about your services, okay, your services, he doesn't know about services. What he knows is he's interacting with load balancer, and then load balancer will distribute the request in the different servers. So if load balancer itself will go down, then your application will crash, right? So that is the issue with load balancer. Now how you can overcome this problem? So there are few solutions. For example, you can use multiple load balancers, okay? So if one goes down, so anyways user can go and send the request to different load balancer, okay? Means request will get sent to different load balancer, or you use different load balancer layer itself, okay? So that is the solution. And so here you are creating multiple load balancers, and this one will call horizontal scaling for the load balancer, okay? This method is called. And then the second one is use the DNS based load balancer, okay? We just saw that in DNS itself, okay, in DNS itself it will have the multiple load balancer, and it will give the IP address of those load balancer, and one of them user will pick, right? So that is the solution, DNS based load balancer and horizontal scaling. Now the next thing is global load balancer, okay? So now what is global load balancer? So there are different types of load balancer, DNS based, global based, okay? So in global based, as name suggests, that so you will have a multiple servers, okay, which is placed in different geographical location, and when user hit the request, okay, it will send that request to the nearer server itself, okay? So that is the global based load balancer. So route user to different data center based on geography. You will have a different data centers, and then the request will go there. So now there are multiple types of routing strategies, like here you are routing on based of geolocation, right, in this load balancer. So you have a different types of routing strategies also. So routing strategy, okay? So what are those strategies? So first one is geo based, what we just saw, okay? So using the location, it will send a request to nearer data center. If that data center is not working, then it will send request to nearer data center, okay? If in India's data center is not working, it will send request to Singapore's data center. So that is how it will work. And then second is latency based, okay? Latency based routing strategy. So let's say if the data center is it doesn't matter that data center is nearer or it is far, okay, which will take less latency, request will go to that data center, okay? Now the third one is health based routing strategy, okay? So in health based, what will happen, it will check the health of a server. If server is down, okay, so it will remove that server from the list, and then will send request to some other server. Now the fourth one is weighted based, okay? So weighted routing, you can say weighted routing. So here this data center or server which has the more weight, request will go to there, okay? So that's it about the load balancer. Now let's see the theory part, okay? So whatever I just explained you in theory, we will see the same thing, okay, but in a structured way. So let me start from here, okay? So now load balancing, explain algorithm types, trade-offs, and Java implementation. So Java implementation will just take one round robin program, okay? So now imagine millions of users hitting your system at the same time, okay? Why doesn't it crash? The answer is load balancing, the silent hero behind systems like Netflix, Amazon, and Google. Now what is load balancing? Load balancing is distributing incoming requests across multiple servers. And why we are distributing it, why we are doing this? Because to avoid overload, okay, overload on a server, and then improve performance of a server, and then ensure high availability, okay? Load balancer acts as a traffic manager that distributes requests across servers to ensure scalability and reliability. Now where it sits in system design, so it sits between your internet and your your user and your web servers. Here you can see external load balancer. Yeah, this is your user, internet, external load balancer, and then your web servers, and then database server. So now client doesn't know backend, right? Client doesn't know about web servers. Load balancer decides which server handles request. So this is what we just discussed, right? Now types of the load balancer. So layer 4, layer 7. Okay, so these are the OSI models, layers, 7 layers, and then this is your TCP/IP models. Okay, the top 4. Then layer 4 is regarding the related to transport layer. Layer 7 is related to application layer. So now layer 4 works on IP and port, but fast but dump. And then layer 7 application layer, so which works on HTTP and HTTPS, and can route based on URL like API versus images, and then header cookies. Okay, layer 4 is faster, layer 7 is smarter, you can say. Now load balancing algorithm. Yes, so we were talking about round robin algorithm. Okay, so here the request will go sequentially to each server, and so this is simple but not good if the server have different capacity. This second one is weighted round robin. So now servers have weights. Okay, so example, server 1 has weight 3 and server 2 have weight 1. So S1 gets more traffic, right, because it has more weight. Now the third one is least connection. So in least connection, send request to server with least active connections. Okay, good for uneven load. Now fourth one is IP hash, so important for consistency. Okay, so same server, same user, same server, means sticky session, you can say. So used for session stickiness. Now consistent hashing, this is what we discussed. Okay, so consistent hashing used in distributed system, and minimize data movement when scaling. Consistent hashing ensures minimal redistribution when nodes are added or removed. Now Java example, if you see, okay, for the round robin, so what you will use here, see, let's say you have taken one list of okay, you have taken one list of servers, okay, and then one atomic integer index, okay, whose value initially is 0. Now what is there in the constructor of a load balancer function? So you're passing the list of servers, okay, and then you're initializing the servers, and then after that wait, okay, and then here when you click on get server, okay, when you click on get server, so what is the logic here? It will just increment the value of that index variable, index.get and increment, and then it will find the mod of server size, okay, and whatever will be the value of I, it will just return that from servers.getI. So this is your main class. Okay, you're just passing list of servers, and then you're creating object of load balancer class, passing those servers, and then from I equal to 0 to 10 you're getting the server. So it will check one by one and will give you that server. So here we have used atomic integer. Why? Because it is a thread safe. Okay, and this one will ensure fair distribution. Okay, now if you see the real world example of a load balancer, so in Netflix or in Amazon, okay, millions of requests per second they get. So the use of load balancer, auto scaling, they use these things there. What is auto scaling? So like when the request the number of requests increase, okay, it will automatically increase the number of servers. If the request decreases, so it will automatically decrease the number of servers. Okay, and then health check also. So using load balancer, auto scaling, health check, they will manage these millions of requests per second. So scenario, if one server crashes, load balancer redirects traffic automatically to different server. Now important concept, so health check. So as we discussed, okay, that load balancer check if server is alive, removes unhealthy servers. Now sticky session, so same user, same server, so needed for session based apps. Okay, you have in old apps we use this kind of things, but the problem is scaling here. Okay, if you scale, they will not get the advantage of scaling because one user is associated with one server only. So then auto scaling, so add or remove servers based on the load. That is what we just discussed. Failover, backup servers takes over. Okay, whenever any server fails, so backup server will take over. Now trade-offs, if we talk about trade-offs, so round robin, it is simple but not load aware. He doesn't know what is the load. He is just sequentially assigning the request to each server. Then least connection, so better distribution but slightly overhead. Okay, and IP hash, session consistency but uneven load. That is the problem with IP hash. Now consistent hashing, so consistent hashing is scalable but it is complex. Now, common interview question if we talk about load balancer. So how does a load balancer handle failure? Okay, so I just describe you health check, right? So a load balancer continuously perform health check on servers and automatically stop sending traffic to unhealthy instances, redirecting requests to healthy ones. Okay, so explanation: load balancer sends health check request HTTP TCP IP ping, okay, using HTTP or TCP IP ping, and then if a server timeout or return 500 error or 5xx 501 502, okay, so it is marked unhealthy. So now what happened next? Remove from routing pool, okay, that server, and then traffic redistribution to healthy servers. So real world example: support 5 servers, 1 crashes, load balancer detect failure in 5 to 10 seconds, and then now traffic goes to remaining 4 servers. So advanced point important, what is, so he will assure that the server which got failed, okay, will have a graceful shutdown, and he used the circuit breaker pattern to avoid retry storms. So if server is failing and we are sending request, okay, so we have a retry mechanism that try 3 times 4 times. But if you don't have that retry, so you will get that count, so you will get retry storm. He will continuously retrying to that server, okay, so in that case it will break the circuit between those two things. So circuit break pattern. Now difference between L4 and L7, okay, so we know that one is faster, second one is slower, okay, and then it will work on IP and port number, it will work on URL header and cookies. So this one is low, intelligence is low, and L7 intelligence is high, okay. L4 works on transport layer, and this one will work on application layer. So now these are the example, okay. L4 server 1 server 2, and L7, like for L7, if he gets /API, so he knows that this /API request should go to backend server. If he gets /images, so he will redirect that request to CDN server, okay, /admin, then secure server, okay. So in short, you can say that use L4 for performance and L7 for smart routing. Now, how do you scale the load balancer itself? So load balancer are scaled using multiple instances behind DNS or another load balancing layer, okay. So what is the problem with load balancer? Single point of failure and bottleneck. That is the bottleneck, okay. What is the solution? Multiple load balancer and DNS based load balancing. So I just describe you what is DNS based load balancing, okay. Now anycast routing also we just talk, okay. So here is the anycast routing, the same IP address it will assign to different servers. Now cloud solutions, AWS, you can use AWS ELB or GCP load balancer for auto scaling, okay. We eliminate single point of failure by horizontal scaling load balancers using DNS and anycast. What is the sticky session problem? The sticky session problem I just described you, okay, that same server, it will go the request to same server. So what is the problem? Uneven load, okay, and poor scalability, adding new server doesn't help existing user, and failure issue: if server crashes, session lost. So then after that, what is the solution for this? Use distributed cache like Redis, or make system stateless, okay. Just use that session information, store that session information in distributed caching. Now how does load balancer work with caching? So that is what we just discussed, right? That load balancer reduces traffic to backend server, while caching reduces repeated computation. Together they improve performance and scalability of the system. So now you can take example of CDN and load balancer, okay. So in CDN also we use the caching. Now distributed cache we discussed, okay. So this is, so final summary if you talk about this. So load balancer ensure availability, okay, caching ensures speed. So together they form the backbone of scalable distributed systems. Now advanced topic if we talk about, so why load balancer become the bottleneck? Why? See, very simple. Load balancer sits in front of all servers, okay. So client, load balancer, and then server. This is the their sitting arrangement, and then that means that every request passes through it, correct. And if it slows down, entire system will get slows down. If it crashes, system goes down, right? Everything depends on that load balancer. So why it become bottleneck? Single entry point, okay. All requests are passing from this only, And then high traffic system, okay, 1 million requests per second hitting load balancer. So load balancer cannot handle, so one queue will build, okay, all the requests will go into that queue, and then latency increase, okay. So single point of failure, if LB crashes, no routing and outage will come. So what is the solution? Solution is use multiple load balancer, okay. Use horizontal scaling of the load balancer. Instead of LB1, use LB1, LB2, LB3, multiple load balancers, okay. So in that case, traffic distributed across multiple load balancers. Now, if you have a 3 load balancers, then 33% traffic will come to each load balancer. Now, and if LB2 fails, so LB1 and LB3 will take care, okay. So now the next thing is DNS based load balancer. So we just saw this DNS based load balancing, right? How does client know which load balancer to hit? Okay, so how it works: when user hit, for example, api.example.com, and then it will go to DNS. DNS will return 3 IP addresses from all 3 load balancers, okay. So user will pick one or use the round robin algorithm. And then in that case, what is the limitation? DNS caching, okay. So client may cache that one IP and then keeps hitting same load balancer, so no real-time health check, okay. So DNS doesn't instantly know if load balancer is down or not, so that request will keep hitting, that client will keep hitting that request to that load balancer. So what is the fixes for this problem? So either you use low TTL, okay, time to leave, and then you combine health aware DNS, right. Just have that mechanism there to check this healthy load balancing server, and then use Anycast. So this is the advanced system. Anycast means multiple server will have the same IP, and now if user hit the same IP, it will go to different load balancer, okay. So this is the real-time architecture of load balancer, okay. So this one here will be the DNS load balancer, and it will send requests to multiple DNS servers, okay. Now Anycast routing also we just saw, okay. Okay, now the next is global load balancing, okay. So in global load balancing, it route based on geography. Global load balancing routes users to different data center based on geography, latency, and system health, okay. So this is the core idea, that user will send the request, and then nearest region will get that request, load balancer from nearest region, and then it will send the that request to server, okay. Now routing strategy we just talk about, okay. Geo based routing, latency based routing, health based routing, weighted routing, okay. Now the challenges, okay, with these routings are data consistency. So data replicate across region can lead to stale read or eventual consistency. So you know the eventual consistency and strong consistency, okay. So it means that if you're updating data in a database, so if it will take some time, so that one will come into eventual consistency, that eventually it will be consistent, but it will take some time. And in strong consistency there itself it will get updated, okay. So somewhere you use eventual consistency, somewhere you use strong consistency. Now cross region latency, if data needed from another region, so it will be slow, okay. If you want data from another server region, then it will be slower, right, because it is far. And cost, multi-region infra is expensive. So if we see the difference between Anycast and global load balancing, okay, what it is, Anycast depends on the network, BGP, okay, border gateway protocol. So you have a multiple networks like cloud network, or you have a multiple networks, right, in a network. So decision maker is BGP here, network for Anycast, and in global load balancing it is an application. Now the control in Anycast is low, okay, because it will send you the IP and it will route it according to itself, but here in global load balancing it is high. In Anycast, we use the same IP. In global load balancing, we use the different IPs. And Anycast, the routing is nearest path, and in global load balancing, the routing is geo, latency, or health based on that. So when to use what? Anycast you use when you need a ultra low latency, okay, or network level routing. Global load balancing when you will use more control business logic routing, okay. So now this is the final architecture. User will send request to Anycast IP, okay, same globally, it will send the same IP address. That IP address will go to nearest region, okay, and from there it will go to load balancer, and then load balancer will hit it to application server, and then it will go to cache or database. So you can say that at global scale, we combine Anycast for fast routing and global load balancing for intelligent traffic control. You can combine both. Ensure low latency, high availability, and fault tolerance. Okay, so load balancing is the bottleneck of a scalable system. Without it, even the best architecture collapse under load. So this is the final thing from load balancing. So thank you.